Hello, welcome again. This is another starter motor diagram. Now, this is not from the usual one, a Mitchell or Data. This is from a Haynes, and the reason I chose this one is a couple reasons. First of all, whether we start from the battery, we always start from the top. As you know, the battery voltage is always from the top. Now, look over here. There is no battery voltage from the top of the page. As we work our way down this way. Look where the battery is right here. The actual symbol for the battery is right here. So it's a little confusing, but you can't always assume, as a rule, it's not always you'll find B plus up here. It depends on the manufacturer of the diagram. So taking that into consideration, starter motor relay that we've done so many times before, let's pick out the most important symbols, components that catches our eye before we start reading a schematic. Most important thing that catches our eye always is a relay in every circuit. Other thing that catches our eye is ignition switch. Okay? Park neutral position switch, abbreviated PNP, also catches our eye. What also catches our eye is this is the most important part. Powertrain control module, abbreviated as PCM, which is the computer, the main computer that controls the relay, which controls the starter motor, which is right here. Here's the starter motor. Now you have three lines coming from the battery. Okay, let's start first. You have three thick wires. First of all, you have one thick wire going through to the fuse panel. You'll see it, and in this one, it's a red wire. It's a thick one, because a lot of current flows through here. Through the fuse panel, it gets separated or split up to all the current through all the systems that need the current. Number two, we have another red wire, two red wires, one thick red wire going to the starter motor, which has all the amps, 200, 300 amps, depending how many cylinders, going to the starter motor. So far we have two thick wires. Another one that we have is from the alternator. Is the alternator. Remember, the alternator has to recharge the battery? Another one then. So another one, a red one, through a fusible link, which is two wires melted together, connected together, which will melt at a certain temperature, like a safety valve, like a fuse. So we have one red wire, two red wire, three red wires going to the battery over here. Okay, the black goes to a physical ground over here. Over here, it doesn't show you the engine block or wherever it's going to, or the transmission, but black is negative over here, and everything red is positive. Now, as we said over here, we start with very important components. When we look at a diagram, we're not concerned with the wires. We're not concerned with the wires here. We're not concerned with the fuses. We're just looking for things that grab our attention. The grabs our attention are these type of components, especially the PCM. Let's start over here then. Okay, we start over here. First of all, let me zoom out. In order for the starter motor to be analyzed, first we have to have current flowing to the solenoids. A holding solenoid and a pull-in solenoid that we went over in a different video. I went through that. Now, when that happens, then this red wire has current flowing through it with 200, 300 amps, whatever it is, to the starter motor itself, which is connected to the ground. Which happens first? This one or this one? This happens first. Think of this like a relay. This is the switch. Whenever you see this type of symbol, first this happens, then the switch is closed to B in this position. So first this happens. Now we come to the relay. Back up to the relay. This switch closes. But in order for this switch to close, what has to happen first? If you said this has to happen first, you're correct. So therefore, we need current to flow here. Then this could be activated. Then this could be activated. Then this can be activated. This switch. This is the hard part. How do we activate him? To activate him, So activate him. Now this is the tricky part. Let's start over here. Battery, current flowing here. It gets to this point. This switch has not flipped, so it's open circuit. The current says, okay, you know what? I'm waiting at this point. I'm waiting here. I want electrons to flow. Where do I go now? Can't go this way. Cannot go that way. Goes through the fuse, ignition 4. A fuse 34, 40 amps. Identified as ignition A fuse. Located where? On the hood fuse block. The red wire, like we said, goes over here. Again, the red wire goes over here and goes to where? The ignition switch. Where can the current flow? Still a red wire. Where does it go now? The only one that has a connection is, if you said in the start position, you're correct. No other position do you see a wire connected. We flip it in the start position, and now it goes through a yellow wire. Not a thick wire, a thin wire. This doesn't carry much current. Now it goes through a crank fuse, 10 amps. Beautiful. It goes out of the fuse, goes through a purple wire. That purple wire goes through, guess what? Goes through still same purple wire, crank volt. And what is this part of? Look at this dotted line over here. The computer, the PCM. Very important. Why did I say this is tricky? Why did I say that? You know that a relay, the control side of the relay needs a positive voltage and a ground. The positive we have to get from the B+. The negative, we have to see where we can get it from. If you said the computer, probably, you're right. But before that, let's analyze how we come to that. So we're not dealing with this part yet. This is not triggered. This is the tricky part. And I had to go over it a few times, actually. We're giving B plus first. The first thing is first to the PCM. We're giving it B plus is 12 volts to the purple wire to get this started. It needs B plus just like a relay needs B plus. So the computer has the 12 volts. Fine. You see there are two more connections going. Crank signal request and starter relay. Guess what each one is for? Think about that. Remember we had air conditioning also going to a PCM. When you open the switch to put the air conditioner on, you're making a request from the computer. It went to the pin of the computer for air conditioning, and it acknowledged your request. Same thing over here. When you are closing this switch over here, in the start position, this over here, computer gets to 12 volts. It knows that the person now is starting the car with this trigger. You could call it a trigger. Now comes the other part of the formula. We have another fuse, ignition E, fuse 22, 10 amps under the hood. All of this and dotted is under the hood. Hot at run and start. So actually in start, this will give 12 volts. But in run or start, this fuse will work. This will only work in the start position. This fuse will work in either run or start. You don't see any connection from here to here because it's connected to another part of a diagram. They didn't put every line. Anyway, now comes again the challenge of how to figure out this type of diagram. We know we need two things. We know we need the relay to trigger. Number one. Number two, we know this control. I call it the input. I call this 86. Here, let's make it easier. Like I always do this. We need 86. 86 is this one. 86 is this one. We need 85. 85 is this one. We need this to get current flowing. So 86 in this one is the B plus. 86 gets the 12 volts. 85 goes to the computer. That means it needs the ground. But before that happens, look at this point over here. The fact that the computer says crank signal request, the magic word here is request, and that's what made me the hint. That means it needs a 12 volts over here as a request, telling it, now I have to give what to this relay? Now I have to give it a ground. This magic word over here, request, filled in the formula for me. Because when I first saw this, we probably had all the same thoughts as viewers, and we said, why do I need 3 wires to go to PCM? Why? I just need a ground. What's the problem? The problem is he gets a request signal. How does he get a request signal? Number 1, park neutral position, that you are in park or you are in neutral. That's number 1. Hint number 1 to the computer. Hint number 2, you're in the start position. You're ready to crank. You put your key in the ignition switch. You're ready to crank. Hint number 1 to him. Hint number 2, you're in park and neutral. Now I'm ready to start to give a ground to this relay. You see how you have to work, you have to look and analyze. Tricky. That's why I chose this type of diagram again. This is for GMs, for a Trailblazer actually. Doesn't matter. The concept is the same. So here, let's go over it again. Let's go over it again. 12 volts over here goes to the fuse, and then it goes to crank voltage over here. Okay, then it goes through the park neutral switch over here, and then as a request. When he gets that, he says, okay, now I'm ready to acknowledge your request. I will give you a ground. How do I know this is a ground? Because he gets 12 volts. The same 12 volts that are fed to him is the same 12 volts that comes to here, to this side, to 86. 86 gets to 12 volts. 85 now gets the ground. Now what happens? Now we're ready to fill this part of the equation. Remember we said before, the current is waiting over here? Well, it took a detour. It went this way, over here. As soon as that current split up, right? Let's say 40 amps is over here. 40 amps is, let's say there's 30 amps, maybe about 80%, 70% of the fuse rating. Usually I go by about, if the fuse is 40 amps, I expect to see maybe 30 amps, 25 amps, probably around 30 amps. Not 39 amps, probably around 30, let's say, for that. But anyway, that current flows here. Can it flow here now? Sure can. He acknowledged your request. He gave you a ground. See how kind he is? At 85, he gave you a ground. Now he energized this, and this will be pulled in. So now what happens? 87, this is 8 and a 7, is connected to 30. So 30 is connected to 87. Now current can flow in this direction. Why? Because the computer gave him a ground. And why was that? Because he got a request. From what? From the parking, because you are in park and you are in neutral. And what else convinced him? 2 things convinced him. You were in the right position with the gear selector. What else? You gave him a 12 volts by cranking the ignition switch. You convinced him 2 times. He says, I'll acknowledge you. I will acknowledge you. I will close this switch from 87A to 87. This is closed right now. Don't worry about this. This is the rest position when you see the symbol on the relay. When it gets, activated, this switch is now here. This is what the symbol doesn't show people, and they get very confused. The symbol shows you at rest on the relay itself. It doesn't show you when it's activated. But always remember, this symbol is like this symbol. See, this is like 87A. But 87 is this now. connected to this. See the yellow one I put over here? It's yellow. Remember that all the time. Now what happens after this? Guess what? Now we're in business. Now we are really in business. And now it's the purple wire. Current can flow here to what? To do this. To activate him. To activate the solenoids, right? In the starter motor. And what will happen after that? Now all that current of 200 amps or 300 and whatever it is, now it can start to start a motor. The pinion gear will spin, and what will it do? It will engage the ring gear of what? The flywheel, and then the crankshaft will start to turn over. Tough video and a tough schematic to understand. But again, I chose this because I want you to be familiar with, number one, as I started the video, it's 15 minutes into the video. I hope after 15 minutes that you say, you know what? Now I really understand this a little more clearer than I understood before. This was a test of your knowledge, because I've seen very few of these. You need, usually the computer gives you a ground and that's it. That's all the important role that the computer, not this one. This is a Trailblazer, crank, signal request, and this. How do I know that it needs this? How do I know? Because you know how I know? What's between here and here? What's between the ignition switch and the computer? Nothing but a wire, a yellow wire, a fuse, and a purple wire. In other words, when I crank the ignition switch, I have to go through something. And what is that something that's in between here? In this case, a computer. That's the only thing that's in. So that tells me if I want to crank this starter motor, I have to go through the computer. And that's the line that goes through the computer. That's how you figure it out. Troubleshooting. Again, I made a video, like I said so many times. In the beginning, that video had very low views. And that video was how to test relays in circuit for starter motor and for fuel pump relay. And I think people were not familiar with my technique. But I did receive some comments from viewers who said, now I understand your technique. And now when I looked at the video, I understood it better. Because first we went over this. You only have to measure one point. And what do you think that point is? If you saw my videos, go back to watch those videos. How to measure relay in circuit. This is the relay in the terminals, in the fuse board, in the fuse box. I don't take out the fuse. I don't jump these two. What do? I took, like I told you, I took a piece of wire. A piece of wire, not a piece of solder. Somebody left a comment, can I use a piece? No. A piece of solder will break. And then you'll have shorts. Don't use that. Don't use those back pros and T terminals, whatever they call them. Those are too thick. That piece of wire that I used, and look at that video. Look carefully the type of wire that I used. And I'll even show you. Let me pause and I'll show you the type of wire. Welcome again. Explaining before the type of wire that I used right here. This is the type of wire that I used. You see this wire? This is the wire. It is the best type of wire to use. It is thin, it is bendable, and it goes into the terminals under these, and you can push this relay all the way in, no problem. I use it for the connectors. Go see the video how to test intake air temperature sensor and others. You'll see I put this wire in there. No problem. It fits into the most smallest places. Do not use that. The T terminals, whatever they use, they are too thick. They are not good. Those back probes, those are too thick. This, as you can see, this is very bendable. Best type of wire to use, and thin, no problem. Not solder. Solder will break off into parts. Now, continuing with this again, I want to troubleshoot this. Where do I go? As you know, as you've seen in the videos that I showed you before, I always select, let me zoom out. I always select this point. This, in a nutshell, will tell me all of this is working in one shot. And that's the video that I made. That if you go to it, now you will understand, and you will understand my craziness, how I go about troubleshooting things. If I go over here and I measure 12 volts, what does that tell me? Where's that point over here? 87. Look at 87. Right here. If this is 87, that tells me what? This switch is closed. Why is this switch closed? Even if I don't have a wiring diagram. Let's say I don't have one. When I go to 87, it tells me this switch is closed. Why? Because this one has current flowing through it. Why does current flowing through it? Because B plus is here. And what else? 85 has a ground. Okay? So even if you have no wiring diagram, let's say I'm working on the GM, Asian car, whatever, Toyota. I pull out this relay. I pull it out. As soon as I see this one over here, I take that piece of wiring, I put it right into there, and I measure 12 volts. I'm done. That's it. All of this is working. My next analysis, 12 volts, where would your next step be? My next step would be now to go to the starter motor itself. Or maybe this one is not working. I could put a clamp meter across this and see if it's getting current. But remember, you're not going to get... If you get current, this will fall. This won't be 12 volts anymore. This might be 11 volts. This might be 10 volts, 10.5 volts. If you're in the first place of getting 200, 300 amps, you just drain the whole battery. You're not going to get 12 volts here. You're going to get 10 and a half, whatever it is. So if I expect to put a meter over here and expect to measure to 200 amps, that's wrong. I expect to measure maybe no current or very little current or broken wire over here. So if I measure 12 volts over here, that tells me this is flipped. That tells me... The fact that I have 12 volts over here tells me what? Tells me that this fuse is good, and what? This wire is good from the battery, the red wire. What else does it tell me? It tells me that this is good. Why is this good? Let's go backwards in logic. Okay? Let's think logically. This channel is trying to open up your knowledge and to try to test you. Okay? Why is this working? You're going to say because it gets 12 volts from here. Why did it get 12 volts? Finish the sentence. Because there's a fuse is good. And what else? Finish the sentence. Because I'm either in park or neutral. If you said that, correct. What else? What else has to happen before I get 12 volts over here? You said this one? Good. That's a good response. I like that if you said that. What else has to happen? This has to get 12 volts. If you said that, good response. I like that. What else? If you said this starter switch has to be in the start position, and this fuse has to be good, and this purple wire has to be good, and what else? The crank voltage has to get 12 volts in the purple. That means the PCM got what? His 12 volts. That means the PCM got his 12 volts through the park and neutral switch. And what else? And it means that he gave him a ground. That 12 volts told me all that information. You're asking yourself? Sure did. Sure did. The fact that I got 12 volts over here, tell me one more time in conclusion, I'll repeat it. Very important. If you understood this logic, my craziness, you'll understand the video how to test relays and circuit for starter motor and a fully pumped. One more time. It's a long video, but